Welcome to Beep Beep Boop Boop. Have you ever wondered what it really takes to build an application like ChatGPT? Not just a flashy demo, but a real production ready product that millions of people can rely on. It's a question that's been on my mind a lot lately. We see these incredible AI tools emerge, and they seem like magic. But as a developer, I know that behind every piece of magic there is a mountain of engineering. And it turns out the engineering for this new wave of AI is different. My name is Baris, and I'm a full stack developer living here in Poland. I spend my days deep in the TypeScript ecosystem, building and thinking about how to make software work. And for a while now, I've been fascinated by the rise of foundation models. It feels like a paradigm shift, similar to the jump from desktop software to the web. It's not just a new tool, it's a new way of building. That's why I was so excited to pick up AI Engineering, Building Applications with Foundation Models by Chip Huyen. I hope I pronounced her name correctly. It promised to be a comprehensive guide to this new world, and let me tell you, it did not disappoint. This book is a must read for any developer trying to navigate the shift from traditional software development to building with AI. It's not about the hype, it's about the how. It's about the architecture, the trade offs, and the hard won lessons from the front lines of AI development. So, in this episode, we are going to deep dive into Chip Huyen's AI engineering. We are going to unpack its most powerful ideas, explore the key concepts, and figure out what it all means for us, the builders. Here is our roadmap for the hour. First, we will get to know the author, Chip Huyen, and understand the context in which this book was written. Then, we will break down the book's central thesis. What is AI engineering and how does it differ from what came before? After that, we will take a deep dive into some of the most critical concepts, like the different ways to adapt models, from prompt engineering to fine-tuning, and the immense challenge of evaluation. Finally, we will look at all of this from a developer's perspective, connecting these ideas to our daily work and offering a critical look at the arguments presented. By the end of this hour, you will have a solid understanding of the principles of building applications in the age of AI. So, let's get into it. Before we can appreciate the what of the book, we need to understand the who and the why. Who is Chip Huyen and why did she write this book? Chip Huyen isn't just a writer. She is a practitioner who has been at the intersection of AI and systems engineering for years. She's worked at NVIDIA and Snorkel AI, founded her own AI infrastructure startup, and even taught machine learning systems design at Stanford. Her previous book, Designing Machine Learning Systems, is considered a classic in the field. So when she talks about production AI, she's speaking from deep, hands-on experience. This book, AI Engineering, was published in a very specific moment. The first edition came out in late 2024, a time when the world was still reeling from the explosive arrival of ChatGPT. For the first time, powerful foundation models were accessible to every developer through simple APIs. This created a gold rush. Everyone was trying to build the next great AI application, but there was no manual, no established set of best practices. We were all figuring out as we went. The core problem Chip Huyen addressed is this very chaos. She saw that building on top of pre-existing foundation models was fundamentally different from the traditional machine learning engineering that came before it. Traditional ML engineering was about building models from scratch. It involved a ton of work in data labeling, feature engineering, and training. AI engineering, as she defines it, is about adapting these massive pre-trained models to solve specific problems. It's a shift from being a model builder to being a model adapter. This book was written to be the guide for this new discipline, to provide a framework for thinking about and executing on this new type of engineering. So what is the central thesis of AI engineering? If I had to boil it down to one core idea, it's this. The advent of powerful, accessible foundation models has created a new engineering discipline, AI engineering, that is less about building models from scratch and more about skillfully adapting these existing models to create valuable real world applications. This isn't just a small change, it's a fundamental shift in where the engineering effort lies. Let's look at this from a couple of angles. Think about the history of software. In the early days, if you wanted to build a complex piece of software, you had to build everything. You wrote your own memory management, your own networking code, your own UI components. Over time, we developed layers of abstractions. Operating systems handled the hardware. Frameworks like Ruby on Rails or Django handled the web server. The database interactions and request response cycle. As a modern web developer, you are not building a web server from scratch. You are using a powerful pre-built foundation, the framework, and adapting it to your specific business logic. Chip Huyen argues that foundation models are the new framework. They are this massive general purpose capability that we can now leverage. The engineering challenge is no longer about the raw training of the model, which is incredibly expensive and concentrated in the hands of a very large organizations. The challenge for the vast majority of us is in the last mile. The process of taking a general purpose model like GPT-4 or Llama and making it to do something specific and useful, reliably and efficiently. Another way to think about this is to compare it to working with a database. As a developer, you don't build a database like PostgreSQL from scratch. You take this incredibly powerful general purpose tool for storing and retrieving data, and you learn its language, SQL, and its best practices. You design schemas, you write queries, you optimize performance, you're adapting the database to your application's needs. In AI engineering, the foundation model is your database of intelligence, and techniques like prompt engineering, RAG, and fine-tuning are your query languages and optimization strategies. The core engineering work has moved up the stack. This thesis was so important because it gave a name and a structure to what thousands of developers were experiencing. It validated that this wasn't just ML light or prompt fiddling. It was a new and complex engineering discipline with its own set of principles, challenges, and best practices. It provided a roadmap for moving from a cool demo to a robust production-ready AI product. Now we get to the heart of the book, the deep dive into the key concepts of AI engineering. This is where Chip Huyen gives us the tools and frameworks to actually build these applications. We will explore four of the most critical ideas: the spectrum of model adaptation, the architecture of a RAG system, the critical role of evaluation, and the often overlooked challenge of inference optimization. Let's start with the spectrum of model adaptation. This is probably the most practical and immediate takeaway for any developer. If you have a foundation model and you want it to perform specific tasks, how do you do it? The book lays out a clear progression of techniques, from the simplest to the most complex. At one end, we have prompt engineering. This is the first and easiest way to adapt a model. It's about crafting the perfect instructions to guide the model's behavior without changing the model itself. Think of it like being a great manager. You don't need to retrain your employee. You just need to give them clear, concise instructions with good examples. For instance, instead of just asking a model to summarize this document, a good prompt would specify the desired length, the target audience, and the output format, maybe even giving an example of a good summary. The book emphasizes that this isn't just about simple instructions. It's a systematic process of experimentation and evaluation. Moving along the spectrum, we have Retrieval-Augmented Generation, or RAG, RAG. This is the next level of adaptation. The core idea of RAG is to give the model access to external knowledge. A foundation model's knowledge is frozen at the time it was trained. It doesn't know about current events on your company's private data. RAG solves this by retrieving relevant information from a database or a set of documents and adding it to the prompt's context before the model generates a response. My favorite analogy for RAG is an open book example. A model answering a question from its internal knowledge is like a student taking a closed book exam. They have to rely on what they have memorized. A model using RAG is like a student who can bring the textbook to the exam. They can look up the relevant facts to construct a much more accurate and detailed answer. This is incredibly powerful for applications that need to be grounded in specific, up-to-date information, like a customer support bot that needs to know your company's latest policies. The book details the architecture of a RAG system, which involves a retriever to find the relevant information and the generator, the LLM, to synthesize the answer. Finally, at the most complex end of the spectrum, we have fine-tuning. This is where we actually change the model's weight. If prompt engineering is like giving good instructions to RAG, if prompt engineering is like giving good instructions and RAG is like giving an open book, fine-tuning is like sending your employee to a specialized training course. You are teaching the model a new skill or adapting its style to better match your needs. For example, you could fine-tune a model on your company's internal emails to make it adapt your specific communication style. The book makes a crucial distinction. RAG is for facts, fine-tuning is for form. You use RAG when the model lacks knowledge. You use fine-tuning when the model has the knowledge but needs to behave differently or follow a specific structure that's hard to achieve with prompting alone. This spectrum from prompting to RAG to fine-tuning is central to the book's thesis. It provides a clear framework for any developer to think about how to solve their specific problem, starting with the simplest, cheapest method and only moving to more complex ones when necessary. Next, let's talk about that might be the single biggest hurdle in all of AI engineering: evaluation. Chip Huyen dedicates 2 entire chapters to this, and for a good reason. If you can't reliably measure whether your application is working, you can't improve it. The problem with evaluating generative AI is that there is often no single right answer. If you ask a model to write a poem, how do you score it? This is different from traditional software where you can write a unit test that checks for a specific expected output. This open-ended nature makes evaluation incredibly challenging. The book explores several methods, but one of the most fascinating is the concept of AI as a judge. This is the idea of using another powerful language model, like GPT-4, to evaluate the output of the model you are testing. You can give the judge model a detailed rubric and ask it to score a response based on criteria like relevance, coherence, or factual consistency. For example, you could ask it, on a scale of 1 to 5, how well does this answer address the user's question based on the provided context? My analogy for this is like using a senior developer to do a code review for a junior developer. The senior developer, the judge model in this analogy, has the experience and context to assess the quality of the work in a nuanced way that a simple automated linter couldn't. The book shows that studies have found a surprisingly high correlation between the judgments of AI models and human evaluators, sometimes even higher than the agreement between 2 humans. This is a game changer because it makes automated scalable evaluation of subjective outputs possible. However, the book is also clear about the limitations. AI judges can have biases, like favoring longer answers or being influenced by the order in which options are presented. This critical perspective is vital. It's not about blindly trusting AI judges, but about using them as a powerful, if imperfect, tool in a larger evaluation pipeline. The third pillar we will explore is inference optimization. This might sound a bit dry, but it's where the rubber meets the road in terms of making AI applications practical and affordable. Inference is simply the process of using a trained model to generate an output. For large language models, this process can be surprisingly slow and expensive. The book explains that every token generated by a model like GPT-4 costs compute and therefore money. An unoptimized model can lead to a terrible user experience and a bankrupting cloud bill. One of the most interesting concepts here is speculative decoding. Autoregressive models, which are the basis of most chatbots, generate text one token at a time sequentially. This is inherently slow. Speculative decoding speeds this up by using a smaller, faster draft model to generate a chunk of text, and then having the larger, more powerful target model verify that chunk in parallel. Think of it like working with a junior assistant. You ask your assistant, here in our analogy, the draft model, to write a draft of an email. Then you, the senior manager, the target model, quickly scan the whole draft to approve it, rather than writing it word by word yourself. If the draft is good, you have saved a ton of time. If not, you only wasted a little time on the verification. This technique can dramatically reduce the latency of generating long responses without sacrificing quality. Finally, let's touch on the architecture of an AI system. The book lays out a clear step-by-step approach to building a robust AI application, starting simple and adding complexity as needed. It begins with a basic model, API call, and it progressively adds layers. First, you enhance the context with RAG. Then you add guardrails. These are safety checks on both the input and the output. For example, an input guardrail might scan for and remove personally identifiable information before it's sent to a model API, while an output guardrail checks the model's response for a toxicity or factual inconsistencies. Then you might add a model router. This is a brilliant and cost-effective idea. Instead of using your most powerful, expensive model for every single query, a router, which is often smaller, faster model, first classifies the user's intent and routes the query to the most appropriate model. A simple factual question might go to a cheap, small model, while a complex reasoning tasks get sent to the big guns. It's like a smart dispatcher in a logistic company sending a bicycle for a small local delivery and a truck for a large, long-distance one. This layered architecture, from context to guardrails to routing, provides a practical blueprint for building AI systems that are not just capable but also safe, efficient, and scalable. Now let's bring this all together from a developer's perspective. How does this book change the way I or any developer should think about building software? First, it profoundly reframes the skill set. For years, the path to working in an AI system seemed to require a PhD in machine learning. This book argues that the most in-demand skill now is not model training, but model adaptation. As a full-stack developer, this is incredibly empowering. My skills in system design, API integration, and building user interfaces are more relevant than ever. The book shows me that I can leverage my existing expertise and learn these new adaptation techniques, prompting, RAG, fine-tuning, to build powerful AI features. It's about combining the logic of code with the intelligence of models. For example, in my work with TypeScript, I can now think about building a RAG system where I retrieve relevant code snippets or documentation and feed them into a model to help generate more accurate and context-aware code. The book was filled with what I would call strategic insights from its examples. It doesn't just give you code, it explains the why behind the architecture. For example, when discussing prompt decomposition, it explains that breaking a complex task into a chain of simpler prompts is not just about getting a better result. It's about creating a system that is more debuggable, monitorable, and easier to maintain. When a single monolithic prompt fails, you have no idea which part went wrong. When a chain of prompts fails, You can inspect the input and output of each step, pinpoint the failure, and fix it in isolation. This is a principle every seasoned developer understands, and seeing it applied to prompt engineering was a real aha moment for me. But a deep dive wouldn't be complete without a critical perspective. The book is fantastic, but it's not without its limitations. One area where I think the book could be challenged is in its optimism about the pace of progress. The field is moving so fast that some of the specific techniques or benchmarks mentioned might become outdated quickly. For example, the constant race to expand context window might reduce the necessity of some complex rack strategies for certain use cases. A 1 million token context window changed the trade-off significantly compared to a 4,000 token one. Another critique is that while the book provides an excellent framework, the reality of implementing these systems can be even messier. The last mile problem of getting an AI application from 95% accuracy to 99.9% reliability can be exponentially harder than the book might suggest. This is where subtle bugs, unpredictable user behavior, and the probabilistic nature of these models create a whole new level of engineering challenges. The book acknowledges these issues, especially hallucination and inconsistency. But the sheer difficulty of solving them in a production environment is something that can only be truly appreciated through experience. Finally, while the book focuses on the how, it spends less time on the should we, the ethical implications of building powerful, autonomous agents are vast. The book touches on safety and guardrails, but the deeper question about the societal impact of automating certain tasks or the potential for misuse are largely outside its scope. This isn't a flaw of the book. It sets out to be an engineering guide, but it's a necessary context for any developer working in this space. We are not just engineers. We are building tools that will reshape society, and that carries an immense responsibility. So, to wrap up our deep dive into Chip Huyen's AI engineering, what are the biggest takeaways? First, the game has changed. AI engineering is a new discipline focused on adapting powerful foundation models, not building them from scratch. Your skills as a developer in system design and integrations are more valuable than ever. Second, there is a clear spectrum of adaptation techniques. From prompt engineering to RAG to fine-tuning. You should always start with the simplest and cheapest method and only escalate in complexity when you hit a wall. Don't jump to fine-tuning when a better prompt or a simple retrieval system would solve the problem. Third, evaluation is everything. If you can't measure it, you can't improve it. In the world of generative AI, where answers are subjective, you need to be creative with your evaluation strategy, using techniques like AI as a judge to create a reliable and scalable feedback loop. And finally, a robust AI application is a well-architected system with multiple layers of defense and optimization. From guardrails that ensure safety to routers that manage cost, to caching that reduces latency, building a production-ready AI product is a serious system engineering challenge. This book, AI Engineering, is an essential manual for this new era. It demystifies the process of building with foundation models and provides a practical, principled framework that any developer can use. My challenge to you this week is this. Think about a task in your daily life or work that is tedious and requires some level of intelligence. Then, using the principles from this book, sketch out a simple plan. Would you solve it with a clever prompt? Would you need to give it some external knowledge with RAG? Thinking through this process is the first step to becoming an AI engineer. Thank you for joining me on this deep dive. This has been Beep Beep Boop Boop. I am Baris, and I will see you next time.